Scientists found a broken comet that acts like it is alive. Yeah, I know how that sounds, like a sci-fi headline you would scroll past while eating chips. But this is not a story about aliens waving at us from space. It is a story about a real space object that behaves in a way we usually only see in living things. It reacts, it changes, it breaks, it heals, and it keeps moving like it has a plan. So what is it? Why is it doing that? And should we be worried? To understand this, we have to start with what a comet is supposed to be, because this comet is not following the rules. A normal comet is kind of like a dirty snowball. It is a mix of ice, frozen gases, and dust, left over from the early days of the solar system. Most of the time, comets stay far away in the cold. They are quiet, dark, and boring. Then one day, gravity nudges one of them toward the sun. As it gets closer, it warms up. The ice turns into gas. The gas pushes dust away, and suddenly the comet grows a glowing head and a long tail. That is why comets look so dramatic. It is not magic, it is basically space steam. Now here is the key part. A normal comet is like a campfire log. It burns, it cracks, and it slowly falls apart. It does not do clever things. It does not act like it is responding to danger. But the broken comet in this story does. Scientists watch it, and it does something strange. It breaks into pieces, then the pieces brighten. Then some pieces fade, then new dusty clouds appear. Then it changes again. It is like it is breathing. It is like it is shedding skin. It is like it is adapting. Okay, that sounds like life. But space rocks are not alive. So what is really happening? Let us talk about what scientists mean when they say broken comet. When a comet gets close to the sun, it can crack from heat. It can also crack from stress. That is when different parts of the comet pull in different directions, because gravity is not the same on every part of its body. If the comet is weak, it can split like a cookie. Sometimes comets do split. That part is normal. What is not normal is when the splitting looks organized, and the object keeps changing its behavior over time, almost like it is reacting to its environment. So imagine you are an astronomer. You are staring at the sky with a powerful telescope. You take images night after night, and you notice something that feels wrong. The comet's glow is not steady, the tail is not steady, the shape is not steady. It is throwing off bursts of dust and pulses. It is changing as it rotates. And when parts of it break off, the new parts do not just drift away quietly. They act like they are doing something. Now, before your brain goes full alien, let me give you the good news. The good news is that we can explain this without any living cell. The bad news is that the explanation is still creepy, because nature can mimic life without being alive at all. Here's the simplest way to think about it. A comet can be like a closed soda bottle that is full of frozen gas. When it warms up, pressure builds under the surface. If the surface is weak, it cracks. And when it cracks, gas shoots out. That gas carries dust with it. The dust makes a bright cloud, and that cloud can look like a puff or a breath. If the comet spins, those jets can turn on and off like a sprinkler. So from far away, it looks like the comet is pulsing. That is not a heartbeat. That is physics pretending to be biology. But we are just getting started, because this comet is not just puffing dust. It is also braking, and the braking changes the way it behaves, which makes it feel like it is adapting. Here is where it gets wild. Some comets are not solid rocks. They can be more like loose piles. Think of a heap of snow mixed with sand, held together by weak gravity and a little frozen glue. If you heat that up, it does not break cleanly. It crumbles, it peels, it collapses. And when it crumbles, it can expose fresh ice that was hidden inside. Fresh ice means more gas. More gas means stronger jets. Stronger jets mean more crumbling. So the comet can enter a cycle. Crack, vent, brighten, crumble, expose new ice, vent again. That cycle can look like it is trying to survive by changing its surface, but it is not trying. It is just doing what weak material does when you cook it in sunlight. Okay, so why would scientists compare it to a living organism at all? Because the changes can be repeated and timed. It is not just one random explosion. They might see it brighten every time it turns a certain side toward the sun, like it has active spots. Then they watch those active spots move or disappear, like wounds healing. Then later, new active spots appear. That is when it starts to feel like behavior. Now, let us zoom in on the broken part, because broken does not always mean dead in space. If a comet splits, it can create a family, a parent piece and many child pieces. Each piece can start acting like a mini comet. Some pieces are rich in ice, so they glow and puff strongly. Some pieces are dusty and dry, so they fade quickly. Some pieces spin fast, some spin slow. Some pieces crack again, making even smaller pieces. From Earth, that can look like a swarm. And when you see a swarm of pieces changing over time, it looks less like a simple rock and more like a colony. Not a living colony, but a physical one. A colony of fragments, each reacting to heat in its own way. Now you might be thinking, okay, cool, but why do we care? It is just a comet. Well, there are two reasons. First, comets are time capsules. They carry old material from when the solar system was forming. If a comet is breaking, it is exposing fresh interior material. That is a big deal for scientists because the inside is less changed by space weather. Second, comets can be unpredictable. And unpredictable space objects make humans nervous because humans live on a planet with a fragile atmosphere and lots of glass windows. So, is this broken comet dangerous? Most of the time, no. A comet that is breaking apart is usually becoming less dangerous, not more. Think of a big ice chunk turning into small ice chunks. Small chunks burn up easier. That is better for us, but there is a twist. When a comet breaks, its path can be harder to model perfectly. Tiny forces start to matter. These forces are not magic. They are like tiny rocket pushes. Remember those gas jets? The comet is basically leaking like a balloon. And if it leaks more on one side than the other, it can get a small shove. Over time, small shoves add up, so scientists track it closely. And this is where the acts alive feeling gets even stronger, because it is not just changing shape. Its motion can change slightly too, because it is constantly venting. It is like a weird natural spaceship with random thrusters. Okay, now let us make this even easier to picture. Imagine a melon made of dusty ice. Inside the melon, there are pockets of frozen gas. The sun heats the outside. The outside crust hardens in some places and cracks in others. Gas finds the cracks and shoots out. Dust follows. The jet makes a bright spot. Then the jet area weakens. That section collapsed. Now a new layer is exposed. The jet moved. The comet changes its mind, but it did not change its mind. The surface changed. And because the comet spins, you get a repeating cycle. The same side faces the sun again, the same pockets heat up again, and you get another burst. That is why it can look like breathing. Now, I want to talk about one more detail that makes this story so creepy in the best way. Sometimes when a comet breaks, it does not just split into a few chunks. It can produce long strings of fragments, like beads on a string. That happens when the comet tears apart gradually, and pieces drift along the same orbit. From far away, a string of fragments can look like a single creature stretching out, and the dust clouds around the fragments can look like a body with a fuzzy aura. So now you have something that looks like a living thing, behaves like it reacts, and even moves with slight unpredictability. But again, it is still not alive. It is just a fragile object being cooked by sunlight and pulled by gravity, and those two forces together can make patterns that feel biological. This is a bigger lesson in science. If something looks alive, it does not mean it is alive. A hurricane has an eye. It has spiral arms. It grows and feeds on heat. It can even die, but it is not alive. A wildfire spreads like it wants something, but it does not want anything. A broken comet can breathe like a lung, but it has no lung. Nature loves to copy the shapes of life because physics creates pattern. Now, what do scientists actually do when they find a comet like this? They do three main things. First, they track brightness. They watch how the light changes over days and weeks. That helps them learn how fast it is losing material. Second, they study the coma and tail. The coma is the fuzzy cloud around the comet's head. The tail is what streams behind it. The shape of these tells scientists about jets, dust size, and gas flow. Third, they try to estimate rotation. If the comet brightens in a repeating rhythm, it might be rotating like a spinning top. Rotation can control where jets point, and that can control how the comet breaks. And then, if we get lucky, a spacecraft might someday fly by a comet like this, because seeing it up close would be unreal. You would see cliffs of dusty ice. You would see jets blasting out like tiny geysers. You might see chunks peeling away slowly, like a wall crumbling. It would look alive, even though it is not. So next time you see a comet photo online, remember, you are not just looking at a pretty tail. You might be looking at an ancient object slowly falling apart, pulsing in the dark, leaving a trail like footprints, and acting just alive enough to mess with your brain. And if you want more science stories like this, the kind that sound like fiction but are built from real space rules, subscribe to the channel. It helps a lot. And tell me in the comments, if you could send a probe to one space object, would you pick a broken comet like this? Or an ocean moon like Europa? Because either way, the universe has a lot of weird surprises left.